we are looking to find the points of inflection for this fourth degree function here. Now, points of inflection, these are points at which the curve changes concavity, maybe concave up, concave down. For example, we might have something like this. We'll do it at the top right here. Here's a curve that's concave down, but then it turns to concave up right here. That would be a point of inflection. And that point of inflection right there, that is going to occur where the hypercritical value is 0. So what we need to do, of course, is find the hypercritical values. So let's start here with the first derivative. F prime of x is equal to, bring that 4 down as a multiplier, it cancels. We get x cubed, and then plus 15x squared, and a minus 5. Now the second derivative is the derivative of the first derivative, so how about 3x squared plus 30x, and we will ask the first question, where is f double prime of x equal to 0? Okay, we don't need to ask the second question because, again, this is a polynomial function, smooth, continuous curve. We never get any of those cusps or corners. So let's try this. F double prime of x equals 0. Well, f double prime is 3x squared plus 30x equals 0. We can factor a 3x out, and we are left with, what, an x plus 10 equals 0. So right here, we're going to get a 0 and then a negative 10. There's our hypercritical values. Now, I'm going to draw a number line here, label it x, and I'm going to put our hypercritical values. We've got one at negative 10 and one here at 0. And what I want to do is to analyze the second derivative. So I'm going to use that second derivative by making substitutions. So what about in this interval right here? Pick some number like negative 11 and substitute it into the second derivative. Now I'm going to write that second derivative up here just to keep it handy. So f double prime of x, and I'm going to write the factored form, which is 3x plus 10. Now, put a negative 11 in here. So if I put in negative 11 into here, now the 3 is always positive, so I know I'm going to get a positive. If I put negative 11 into here, I'll get negative. And then if I put negative 11 into here, I'll get negative 11 plus 10 is negative. And then I get positive times negative, that's positive, which means the curve is concave up, right? So it's looking like this. Now, I was using negative 11. You can use any number at all. If it works for one, it works for every one of them. Now, what about in this interval here? Well, let's try negative 1, easy one to work with. So the 3 is going to be positive. The 3 will be positive. If I put a negative 1 into here, I'll get a negative. So this will be negative. And then if I put a negative 1 in here, negative 1 plus 10 is 9. That's positive. Make that multiplication, and I end up with a negative, which means the curve is concave down, which means it looks like this. And on this last interval here, let's pick some point like 1. So if I put in the 3 is positive, the 1 is positive, we'll make that positive. The 1 will make that one positive. So my sign chart looks like positive, positive, positive. That's equal to positive, which means the curve is concave upward and looks like this. Now, points of inflection occur where we have a change in concavity. So look what happens right at this negative 10. To the left, it's concave up. To the right, it's concave down. So there's a point of inflection right here at negative 10. And then what happens at 0? At 0, well, it's concave down, the curve is. And then on the other side, it's concave up. So right here at 0, we have a point of inflection also. So I'm going to claim now that the points of inflection are at x equals 0 and negative 10.